All right, here we're going to look at two derivatives at no extra cost to you. And they both involve, well, the first one involves an exponent that's not base e, and the second one involves a log that's not base e. In other words, not a natural log. So we'll do the exponent first. So when you look at this, it's a quotient rule. So we're going to follow the quotient rule, but it does have an exponent that's a base other than e. There's a formula for that, but the way I like to think of it is think of it like an exponential function, e to the 3x squared, and the derivative of that would be e to the 3x squared times the derivative of 3x squared. Since it's not an e, all you have to do is then multiply it by the natural log of the base, in this case, which is 5. So here we go. If you like to remember formulas, you should do it that way. So the derivative of this function is the bottom times the derivative of the top. So now I'm taking the derivative of this exponential function. So it's just itself times the derivative of its exponent times the natural log of the base. That is it. Minus, because we're still in the quotient rule, the top times the derivative of the bottom, which is negative. It's a chain rule. Negative sign. Leave the 3x alone. That's the inside. Times the derivative of the inside, which is 3. All over the bottom squared. So now we're just going to clean it up and simplify a little bit. So the very first term, we have a natural log of 5. We have a 6. Well, I think there's so much going on here. I think I'm just going to factor out this 5 to the 3x squared along with this 3 because this one has a 6. So we'll do that as we go. So we have a 3. We have a 5 to the 3x squared. So up top, we have a 2x, because we factor out the 3. That was from here. We have the ln of 5. We factor out the 5 to the 3x squared, so we just then also have a cosine of 3x. So that's the first term. Second term, we factor out the 3 and the exponent, so it's a negative sine of 3x. So change that to a plus. And we're all over cosine squared of 3x. That is it. It's a strange looking answer, but that is it. So now I'm going to do this derivative, and it's coming apart. So this one involves a log, and we're really used to dealing with natural logs. So there's a very, very quick fix to this. If you like to use natural logs, then use natural logs, just using the change of base formula. So the change of base formula, the log base anything, say 5, of anything, say 38, is always the log of 38 or the log of 5, no matter what base you use. So I'm going to decide to use the natural log. So this is the natural log of 38 over the natural log of 5. So that's how you use change of base. You can change any log to natural logs. So this one, I'm going to change it to the natural log of this algebraic expression over the natural log of 7. Just to make it a little bit neater, the over natural log of 7 part is a constant. So just write that as a factor. So there's what it looks like. Now, as usual with natural logs, if you do it smartly, you'll expand it first. So when you expand this, it would be 2 times the natural log of x plus 1/4 natural log of 7x minus x squared. If that wasn't clear to you, you just go back and review the properties of logs. Now the derivative is going to be super easy. So the derivative, 1 over natural log of 7 is constant. And then now we just do our natural logs. So the derivative of natural log of x is 1 over x. And then the derivative of the natural log of this expression is just 7 minus 2x, the derivative, over itself. And I have this 1/4 out in front, so I'll just lump it in there. And that is it. So you can check both of these on Wolfram Alpha or with a calculator, how you learned to do that before. That's it.